the cloud. Also, the recording has started. As you know, we started by going through the energy converters or power converters on board. And we talked about the internal combustion engine, how it basically operates, the fuel cell. You can call it hydrogen fuel cell. It was operating like the power stage of a battery. And we also talked about later the system of the fuel cell. This can be also important that the fuel cell needs also some other components. And we said that we are going to have an electric machine. The electric machines can be different. And we are going to dive into the electric machines on Thursday. Not really dive into, but I will give you a general information. So we already started talking about the types of the electric machines. Then we said that we are going to have converters on board, AC-DC, DC-DC, and DC-AC converters, or bidirectional. It has to be bidirectional. And we talked about the usage of these converters. The first thing that you need to know is this buck-boost converters are quite rare because they add to extra cost and they decrease. They may decrease or increase the efficiency of the system. You need to really decide on the voltage level nicely. So these are not very common, but what we know is for chargers and for the traction, we have to have the third one and the second one on the board. And I think we discussed in detail how can we place this DC-DC converters. I didn't tell you any rules or how we have to do it, but I just try to explain you that what we need to consider. If we need to put a DC-DC converter in some configurations, we have to have a DC-DC converter. Otherwise, we cannot make the system operate. And then we talked about the isolated charging. This is also important. We have it in all the electric vehicles. And we were talking about some examples. So such a drive system I will also talk about today once we finish what is left from here. And the last part was the mechanical to mechanical energy converters. So we have the storage in chemical form in most of the case. We either have some fuel in the hybrid electric vehicles or we store the energy in the battery. So it is also in the chemical form. Then we need to convert it to the electricity. And finally, we need to convert it to the mechanical so that we can have the motion that we require. So this mechanical energy converters actually come in two stages, in two different forms on an electric vehicle. Here I just talk about one form. Maybe it is good to talk about the other form. So what we know is these converters can be needed. So mechanical to mechanical energy or power, it is the same. Let's put it power converters. So the first type of the converters are required directly after the internal combustion engine. So so one is required for after the internal combustion engine. And as you know, the internal combustion engine, let's make it different. So speed reduction, the first type, we can call it speed reduction type of the mechanical converters. So they come after the internal combustion engine. They can maybe increase the speed of the internal combustion engine depending on the speed. My phone is ringing. Speed reduction is used for the electric machines, but let's say speed adjustment. So the mechanical converters, it means that here the input is going to be the mechanical speed, and linear, or usually it is rotating speed that we have on board. And it is going to be the torque, and the output is going to be another speed and another torque. So these are like the transformers that we use in electrical system, or DC-DC converters or DC-AC converters. So here, the first option is the speed adjustment. We can use them directly after the internal combustion engine and the electric machine. So what we have learned is, if we use them after the internal combustion engine, we need a multi-speed gearbox. and we call it a gearbox, multi-speed gearbox. And if we are going to use them after the electric machine, so single speed or double 2-speed gearbox are going to be okay. Single speed, this is the most common one. And maybe 2-speed. So we were talking about some example where we had 2-speed gearbox after the electric machine. And so here we are going to use most of the time the gear sets to adjust the speed. And for the internal combustion engine, this multi-speed gearbox has to be required. That was also asked in the exam, so that since the internal combustion engine has a characteristic, something like that, torque versus speed characteristics. But at the output, we would like to get a characteristic, something more or less, not, it doesn't need to be perfect like that, but it will be good if it is like that. So this is internal combustion engine. This is the required at wheels. So it means that we need to use a multi-speed gearbox so that we can make sure that our system can be translated to the different gear ratios. So each of these curves are going to represent a different gear ratio. And for the electric machine, we don't need this gear ratio because the electric machines already have the characteristics which is close, or if you design them carefully, of course, it will need some effort. So with you can get more or less this characteristics. But the problem with the electric machines is if you want to get a high torque, then your system is going to, the size is going to increase. So the size of EM is going to be related to the torque output, because torque means current, as we will also discuss later. Okay, I cannot write. So torque means the current, and the current means more space. It's opening up. I forgot to save. Okay, it is all done. That's good. I think you cannot see. Let me share screen. Okay, so I was just talking about the gearbox, required gearbox, so the mechanical to mechanical power converters. And the first type is going to be the really speed adjustment of the traction system. And for that, we use it after the internal combustion engine and also after the electric motor. Internal combustion engine, then multi-speed, I'm not going to repeat, then electric machine, usually a single speed is used. And the reason that we use a single speed is to, if we want to have an electric machine with a high torque, it means that we need to have a high size, and we use a single speed so that we can have an electric machine with a higher speed. So here, if this is the electric machine, so the torque of the electric machine is going to be around, say, 200 Newton meters. Speed is going to be around 15,000 RPM. I'm just making the values up. And this is the electric machine shaft. This is the gearbox. And on the other side of the gearbox, for example, if the ratio is 10, I know that the torque is going to be 2,000 Newton meters, and the RPM is going to be, if there are no losses, of course, otherwise we need to adjust the torque based on the losses. The RPM is going to be 1,500 RPM. So if we use the single speed gearbox, we can design a machine with high speed and low torque, and due to that, we can lower the size of the machine. Lower size or smaller size. But on the other hand, of course, we are going to add a gearbox to the system. So at the end of the day, you need really almost the same space, smaller size plus the gearbox. And the second use of this mechanical to mechanical converters can be set that to couple the torque and power and speed of the different mechanical outputs, couple the torque and speed of different sources. So we have learned about these earlier when we talk about the hybrid electric vehicles. We need to use them for hybrid electric vehicles, because in hybrid electric vehicles, we learned that actually we can have two power generators or two traction systems. For example, we can have the internal combustion engine plus the electric machine. And in a parallel hybrid case, we need to somehow make them operate in parallel, or in the power split hybrid case, we need to make sure that they can operate in parallel. The power of the internal combustion engine can be split between the wheels and electric machine and so on. So in hybrid electric vehicles, we said that we can use the torque couplers and also the speed couplers to be able to couple the torque and speed of different sources. And the torque couplers were basically gearboxes, but you need to think that we are going to have or the chain, and I did the same. I need to save it somehow. Okay, it's not gone. So here the torque coupler is a gearbox with two inputs and one output. So we are or multiple inputs and multiple outputs. For example, here this can be internal combustion engine. Here it can be electric machine, and this can be the shaft. And as you know, this is going to couple the torque. The torques are going to add it up. But on the other hand, their speeds must have a fixed ratio. Speed couplers, we learned planetary gearbox. I think this was the carrier, sun, and ring gear. We said that this is going to be same as we discussed many times. It's going to have the planets, it's going to have the sun, planets, and the carrier is going to carry the planets, and we are going to have the ring gear. And in this case, we can again connect, for example, electric machine 1 as in the Prius. And here the carrier is going to be the internal combustion engine, and ring gear is going to be the electric machine 2. Not directly, but let's call it like that. And in this case, we can add up the speeds. Speeds are going to be added, but the torques are going to have a fixed ratio, and you can just combine them. So the second type of this torque and speed mechanical to mechanical converters can be told as the coupling of the different torque and speed inputs and how they are going to go to the shaft. And in this case, maybe you remember there was also a shaft connection through EM2. And that maybe the third part can be taught as what we see here, which is going to be, so here we are also going to have the differential. So the third part, because it is a little different from them as we are going to discuss today. So the differential is there so that first of all, this power can be, or this torque and speed can be divided into the wheels. And maybe it is good to come to here. So differential, we need to have it when we need to connect the two wheels. So far we talked about the gearbox, which we put after the electric machine or internal combustion engine. And I also just wanted to add the information on this speed and torque couplers, because they are also mechanical converters on the board. But so far we haven't talked about the differential yet. And here something, this is not an electric vehicle. Maybe you realize this is an internal combustion engine vehicle, and you see a four-wheel drive system. And if you have a four-wheel system with internal combustion engine, you won't use two internal combustion engines, but you will have just one. and you will have a drive shaft, which is connecting the internal combustion engine with the rear wheel or front wheel, wherever the internal combustion engine is located. It is at the front, and it is connected with this drive shaft. And in what we know is in electric vehicles, we can also have the same configuration. We can just have one electric machine and a gearbox, and we can have a centralized drive. Of course, with the electric machines, we also have the other options, like we can place the electric machines directly in the wheels, or we can put one in the front axle and one in the rear axle. So the electric machines bring some more flexibility into the drive system. If you are going to use an electric machine in the hub, so within the wheel, of course, then you don't need to have a differential. Differential is required only if you are going to drive two wheels with one traction system. Because if the system has to, and this is going to, if you are going straight, this is just going to operate like a torque division. So yeah, it's going to just, they are going to have the same speeds, and the torque is going to divide it to the right and left, so that from one source, you can just divide it into the two wheels if you are just going straight. But on the other hand, this differential is required in all type of vehicles, so that the wheels, and it is required in the driven wheels, you don't need the differential in the not driven wheels, because not driven wheels are going to just follow the driven wheels anyway with their own speed. So their speeds are not going to be fixed. For example, here, the differential is required, first of all, to be able to divide the torque coming from the drive shaft, torque coming from the electric machine to the two wheels. That's the first use. And if you are just going straight, then nothing is going to happen. So the torque and the speed of the wheels are going to be the same. And if you, as long as you go straight, there won't be anything happening within the differential. But the differential also has some, maybe it comes here. So first thing of the differential is connected to rotate in. So it also has some speed reduction. So in addition to the gearbox that we have here, we are going to have some speed reduction in the differential, because it has also this gears and the drive shaft gear ratio and this wheel gear ratio is already going to give you some reduction in the speed. So in addition to this one speed gearbox, we are going to have some reduction in the differential, so the second one. And it also allows to turn off the power flow by 90 degrees. So this, as you see here, this drive shaft, this which has come from, it can come from the electric machine or internal combustion engine. It is just going to rotate in this direction, let's say. And if it rotates in that direction, the speed, this big wheel is going to rotate in the shown direction. So it will also gives us a 90 degrees of power flow direction, so that we can place our rotation direction accordingly. But maybe in some of the electric machines in which the electric machine is directly placed on the shaft, then we may not need this 90 degrees of change. But on the other hand, this connected, if we want the connected wheels to rotate at different speeds, we have no other chance. We need to use a differential. And if you have just one drive for the front wheels or one drive for the rear wheels, then there should be a differential, so that you can connect the wheels to the same traction system. And in this case, there are videos. You can just watch the videos. They nicely explain how a differential works. Here it also explains how a differential works and how the limited slip differential works. So basically, if you just want to have a right turn, I think this is a right turn, yeah. So that the left wheel has to be faster than the right wheel, so that you can take the turn. So if you don't have this differential, of course, you can make this turn, but one of the wheels should be slipping, and which is not good for the control of the vehicle, and which is not good for the wheels. So therefore, we use this system, and in this system, what you see is actually if there is no difference between right and left, this this drive shaft is going to rotate. Then this wheel, the big wheel, is going to rotate with this big wheel. So these parts are connected to this big wheel. So it means that these connections are going to rotate just with the wheel. And as they rotate, if there is no rotation, the relative rotation between the right and left shaft, so these pinions, these planet pinions, are going to be stationary for going straight. And it means that they are just going to make these red things rotate with them. So if there is no straight operation, let's call it straight driving condition. So it means that if you are driving in the straight manner, let me save it. Oh. I opened an autosave, so I have to save. So in the straight driving, let's assume that this driven shaft has a speed, some speed. Let's say, I don't know, let's make it up. I have no idea. Anyway, X amount of speed. And then it means that this shaft is going to have a lower speed because this can rotate faster and this needs longer. Let's say that X divided by 5 times the speed. And if you are driving straight, then of course these connections are just going to rotate with the same speed as the big wheel. And it means that they also have to rotate with the same speed as the big wheel. So if you are driving straight, all of these components are going to rotate at the same speed, whereas these are going to have like spinning, so they can just spin around themselves, is going to be 0. Spinning speed, let's call it spinning speed. Spinning is 0, so they are not going to spin. But on the other hand, if you want them to, let's stick to the same. So they are actually, it is already explained here, nice. Let's make it big. So it actually just says what I tried to explain. If you are driving straight, then all of them are going to have the same speed. So X over 5, X over 5, and this is going to have X over 5, and they are not going to spin. But on the other hand, if you are turning a corner, so we will understand which corner we are turning. So this is going to, if the drive shaft has the speed of X, of course, this is going to have the speed of X over 5. So I just put here a ratio of 5 because I think they looked quite different from each other. But I think normally the ratio is not going to be that much anyway. But in this case, if we are turning, and as you see here, it is rotating faster than this side. So it means that this should be, we need to rotate to the left. And in this case, what you can see is this pinions going to start spinning. And of course, this is going to also rotate with X over 5, X over 5, but the relative speed, so if they start to spin, so this is going to make, maybe it should be the other way around, this is going to make one side faster, and as the other one is also going to spin on the other side. Actually, it is enough also to have just one of them, but I think as the torque and the power increases, then you need many of them. And so the speed is going to be divided between right and left. with the help of the spin of this pinion. So this is more or less like a speed coupling. So there is one speed coming from this big wheel, and you are going to divide it to the right and left. And this division is made based on the spinning speed of these pinions. For example, here, so this is just other way around. We are getting a right corner. I know that this has to rotate faster and this has to rotate slower so that I can get the curve without slipping off the wheels. So if you don't have a differential, this one of the wheels has to spin, has to be slipping. And in this case, as you see that this has to be faster, this has to rotate faster, and this has to rotate slower, so that this pinion is going to spin in the counterclockwise direction. And it means it will allow this gear to spin faster or rotate faster, and it will make that this part is going to rotate slower. So as you can see, they can cancel each other, and here they can add up to each other. So this is basically a speed coupler. It is coupling one's speed of the drive shaft. What is wrong with my computer? Anyway, so it is coupling the speed of the drive shaft, and it is sending some part to the right wheel and some part to the left wheel. And if you are going straight, they are going to be separated equally. If you are taking some corners, then there's going to be a difference. So the problem with such kind of a system happens if one wheel starts to rotate freely. For example, you are driving on an oil, so one wheel is on an oil and the other wheel is on a regular asphalt. And at that point, actually what happens is one wheel starts to rotate quite fast. So this is designed to get the corners, okay, to turn a corner. But what happens if one of your wheels is on oil? So this is one wheel, this is the other wheel. Here we have this differential system. So we are going to see actually electric motors are directly placed on the axle. But anyway, let's assume that like this electric machine system comes from here, and this is the differential. You are driving straight. You want to drive the straight, but there's some other problem, not taking the corners, but here there's some water or ice or oil and something. And if here the total friction is less, so this wheel is going to accelerate, so that so it is actually common sense. If you send here some torque, and the torque is divided to the right and left equally, and in this case what I know is this wheel tries to accelerate, and as it accelerates, it is speed n, let's call it n, this is left and right. During this operation, first of all, you cannot go straight. What will happen? So you are driving and you don't have any ESP, ABS, none of these control systems. And one of your wheels are just on the oil or ice or on a wet grass. Can you go straight if you don't have any ESP?
All the power will go to that slipping wheel, and the other one won't get any torque or power. So you just sleep.
Okay, so but what happens? Can you go straight, Arash, and in that condition? Even if you send here the power, you send all the power here. What happens? Can you go straight?
So you can't, it's just slips if it is just that.
So in this case, you will start spinning like that, right? Or so you will go somewhere else, maybe. So there was a driver. Who was that driver? So from Formula One. He hit very badly. Anyway, I need to find you this it has been a month or so. So there was, I think it was Bottas was driving and he wanted to overtake him. Then this driver came a little like that. And so therefore this driver has to use the rest of the road. And here it was green and wet. And then the driver came all the here and there was a curve, I suppose. And one of the wheels were for a very short time on the green, and then he just hit the car. Do you know what I'm talking about? Have you seen that? Just because of the, anyway, so you don't go to that direction. So, okay, now I understand. So if there is no grab on this direction, your car, here there will be lots of resistance. Here there will be less resistance, and your car starts spinning into that direction. But since we have the ESPs, they will just stop doing that. They don't let it happen. And here the differential is going to send. So this speed is going to quite high, but it is not going to have any grab. So even if it's going to have the very high speed, it is not going to cause any traction because the mu of this place is very less, and you cannot apply any force to the ground, is low. You cannot apply any torque to the ground. And if you cannot apply any torque to the ground, you cannot have any traction. So this wheel is going to basically start slipping. So it's not going to apply any force to the ground. And only this wheel is going to apply force to the ground. So your car starts to spin to your right, in the right direction.
Bottas and Russell, I found.
Perfect. So that was Bottas and that was Russell. I don't know how to write Russell. Anyway, with an H, no H. Bottas and Russell. And the Russell was very mad at the Bottas. Russell thinks that it happened because of the Bottas. But what happened is really I don't know how to write Russell. Let's put just an R. So the Russell was, for a very short time, one of his wheels was on the green, and then there was no traction or very less traction because of this low adhesive coefficient on the grass. So therefore, he almost turned 90 degrees. I think you can watch it. Okay, there's a YouTube from the Ogun. You can watch it, so you will see that the Russell just rotated 90 degrees and just crashed the Bottas. So that if there's oil on one side, the car will rotate in the other direction. But this only happens in the Formula One cars, but not in the real cars, because we have every vehicle causes different ESP, electrical stability, P, I don't know what's P, system, EPS, no, electrical stability something. So they have some systems to stabilize it. If they recognize that one wheel is spinning faster than the other wheel, then they will apply brake to that highly spinning wheel to make sure that the system will drive more continuously with no problems. So this will happen in the Formula One cars because they don't have that. They don't have the electrical stability units they are not allowed to use it because the drivers has to do that. But in regular cars, you don't need to be afraid of that because we have already electronic systems, and the electronic system is similar to the ABS. ABS is for braking, and ESPs are for driving conditions. And the extreme case can be thought as if we have one wheel flying. We can call it a flying wheel. So maybe you know it from the off-road vehicles. What happens if there's some ground like that and one wheel is just not touching to the ground? So most of it is standing with the other wheels. Let's say that the driven wheels. And in this case, so this will spin. and there won't be any power sent to this wheel here. And to overcome that problem, because if you use a regular differential, you have no chance. All the power will be sent to this wheel, and there won't be any traction on the other wheel, so you will stuck there forever. So this is mountain, and this is the wheel of the vehicle. And for that reason, there's some other possibilities, limited slip. So the slip here is limited. They don't let they just let a given difference between the speed of the right and the left wheels. So the speed of the right and left cannot be super different from each other to be able to solve this problem. So you can just watch them, how the differential works. They really explain it nicely. And you can also watch the other one to understand what is a limited slip differential. Okay, so in this case, and as I said, you don't need to worry about that if you have a new car. So they all have the electronic stability systems, so your car will drive perfectly. No worries about that. So that was this is the third part. This was the differential. It has some reduction. It will change the direction of the rotation by 90 degrees. And it will also make sure that you can take corners. So that was it basically for the power converters. And I also, and in the Thursday, so here, we have some commercials, you can watch them. Here there are some videos about the hydrogen vehicles, and these are the textbooks that I used. On Thursday, we will start looking into the electric drive system, the traction system. So the traction system is going to become, I found actually some stuff for you. Nissan was good. Okay, let me share that. Okay, so first of all, do you have any questions so far related to the energy converters? No questions. Let me share the other screen. So in the rest of our lectures, we are basically going to, let me also stop recording.